On this question, you're given the graph of y equals sine x, and it's very important that you refer back to that in pretty much everything else you do. In part A, we've got to sketch the graph of y equals 2 sine x. So, if we just choose some values, significant things are happening at 90, 180, 270 and 360. I'm going to zoom out for a minute so we can try and see both graphs together. When x is 0, sine x is 0. So 2 sine x is 2 lots of 0. So the graph here will go through that point of 0. At 90, sine x is 1. 2 sine x will be 2 lots of 1, which is 2. So the graph will go through here. When x is 180, sine of x is 0. 2 sine x will be 2 lots of 0. That will be 0. When x is 270, sine of 270 is minus 1. So sine x is minus 1. 2 lots of sine x will be minus 2. And that will be down here. The 361 will be 2 lots of 0. So what we are getting here is the graph will look like that. Now I worked it out point by point. But if you ever just have a 2, or any number, multiplied by the function you've got as your original graph, that just multiplies all the height by 2, measured from the x-axis. So for example, if I'd had there y equals 3 sine x, that would have just been 3 times as high. It would have been peaking at 3 and at minus 3. That would still have been 180 and 360. So if you just stick a number in front of a thing and just multiply the whole old graph by a number, you just stretch it vertically when it's measured from the y-axis. So if you look over the page, the next graph we've got to do is y equals sine of 2x. Now again, we need to refer back to the graph of sine x that we've been given as well. So again, let's look through. When x is 90, if x is 90, we've got to work out sine of 2 lots of 90. So when x is 90, we've got to do sine of 180. Sine of 180 is 0. So we know the point will go through there. Let's have a look at when x is 180. When x is 180, 2x is 360. We've got to do sine of 360. Sine of 360 is 0. And when we double these numbers, it goes off the scale from what we had here. So we probably need to look at what happens here when x is 45. When x is 45, which is this point on the graph, 2x is 2 lots of 45 is 90. And sine of 90 is 1. We get that from the one we're given. So that will go through there. When x is 0, 2 lots of 0 is 0. So that will still be at 0, just like the last one was sine 0 is 0. We look here at 135, halfway between the 90 and the 180. When x is 135, 2x is 270. 270, sine is minus 1. So here, sine is minus 1. And if we join those up, we can see what's happening. Now, we will actually be repeating this, and that will go up and down, and we get basically 2 cycles, 2 periods in the same as where it was before. That 2 has effectively pushed things in from the side. Like pressure has been applied here and it's been pushed in. And we actually have twice as many periods in the curve. If I had to do y is sine of 3x, in the same point I would have had 3 repeats in there. So that would have been sine of 3x. The third part of the question, we've got to draw the graph of y equals 2 sine x. Now I've just sketched on the original y equals sine x graph. That wasn't on the question. So that's the y equals sine x graph I've just sketched in, just as a reference drawing. Now, sine 2 plus sine x is exactly the same as sine x plus 2. So at any point on this curve we've got to draw now, it's got to have the same value of the old one plus 2. So here, when x was 0, the old curve had a value of 0. Add 2, takes us to 2. Here, the old curve had a value of 1. Sin x was 1 when x was 90. We've got to add 2 to that. 1 plus 2 takes you up to 3. Here, it was 0. Add 2, takes us here. When x is 270, sin x is minus 1. So that bit of it is minus 1. We've got to add 2. That takes us up to plus 1. 0 goes up here. And what happens in this one is the curve just shifts up 2 units. And if you have in your original graph with a plus 2 on it, that's what happens. It goes up 2 units. If the graph we were given here had been instead sin x minus 1, it would have gone down 1 unit. So again, that's the reference graph, that's y equals sin x. So if I had a minus 1 there, all of these points would have gone down 1, and I would have ended up with that curve.